This animated video is a presentation of the actual events that took place at the Isla refinery during the period from 1989 to 2013, as it relates to Isla's heavy slops tank 3962. Isla had the sludge from the tank removed in 1989 and then again by Scaltech in 2011. This shows the north water drainage manifold of tank 3962, which was used by Scaltech to loosen and remove sludge. It was also the connection used by AGC to remove slop oil. The silver colour pipe coming out of the wall on the right and connecting to the tank is the 6-inch pipeline through which the tank is fed with slop oil. This shows the west water drainage manifold, which was also used by Scaltech to loosen and remove sludge. It was also used by AGC to remove slop oil with a vacuum truck. The white vertical pipeline with 4 connections to the tank is the 6-inch oil decant manifold that Isla uses to decant oil from the tank. This shows the northeast water drainage manifold. All of the water drainage manifolds are used to remove water from the tank. This is the one that AGC used to remove most of the slop oil. We are now seeing a 3-dimensional view of tank 3962, prepared by a Scaltech expert in tank design and prepared from data and pictures taken of tank 3962. It shows the location of the inlet pipe and all of the outlet pipes of tank 3962. There are no other pipes or connections of the tank that allow removal of material. This is a 4x4 meter door panel used by Isla to enter the tank and remove sludge with a loader and to perform maintenance on the tank. This claim is about the fact that Isla states in a report of February 2013 that it looked into the tank through a hole in the wall in April 2012. After Scaltech announced that it had finished this project, it turned out that approximately 4.2 meters of sludge was still in the tank. The court allows Isla to prove with witnesses or in any other way that tank 3962 contained 4 meters of sludge in April 2012. But it is true that Isla did not call in Scaltech when it noted, according to Isla, that the tank still contained 4 meters of sludge. Whether this should have repercussions will be decided later. We are now in year 1989, when Isla had the tank cleaned, the last time before Scaltech cleaned the tank in 2011. The tank at the time was cleaned conventionally. First, Isla decanted the floating oil through the oil decant manifold. Then the dirty water was removed by connecting a vacuum truck to the water drainage lines until all liquids from the tank were removed. The dirty water was transported with a vacuum truck to Isla's land treatment cell, where the water drains out and solids accumulate. After removal of all of the liquids, Isla cut a 4x4 meter door sheet into the tank to allow for a loader to enter. The loader removes the sludge from the tank and loads it into a dump truck. The dump truck takes the material to an area of the Isla refinery called Goat Island, where Isla stores all oil-contaminated solid material like sludge. Isla then welds the door sheet and starts using the tank for its slop oil operations. Isla continuously fills the tank with slop oil. Oil and water separate from the slop oil and the remainder becomes sludge. Oil is decanted via the oil decant manifold. Water is drained through the 5 water drainage manifolds. The solids in the slop oil precipitate to the bottom of the tank in the form of sludge. This is what is referred to as the sludge with 50% solids content. By April 2011, tank 3962 had accumulated 4.38 meters of sludge in its bottom. More than 80% of hydrocarbons waste generated within a refinery is reused, reclaimed or recycled, with the remaining 20% eliminated by an acceptable disposable method. From a disposal perspective, the waste materials generated at different unit operations within a refinery can be conventionally segregated into 2 groups: oily waste or sludge waste. The main difference between oily waste and sludge waste is related to the amount of organic and inorganic solids in the waste stream. Scaltech had to remove 33,000 barrels of sludge with the composition specified in the agreement from the tank and process them. For Scaltech had to remove the solid substance from the bottom of the tank, consisting of solids for approximately 50%. This is a sludge sample with 50% solids content and 30% oil. The sludge is a solid mud. It is difficult to handle and it does not flow at all. Isla describes it as a packed solid mass. Isla's online tank cleaning claim is based on a performance report of Isla's technical department that states the tank had been in service since 1989 and had accumulated considerable quantity of sludge. The projected sludge quantity in the proposal was 33,000 barrels with the following composition: solids at 50%. The operation was contracted to be online, keeping the tank in service. There was 438.3 centimetres of thickness of sludge. Isla's RU expert report verified the report of Isla's technical department and states that there were 32,948,000 barrels of sludge in tank 3962 in April 2011, with a height in the tank of 4.38 metres. He also states that Isla added 1,000 barrels of sludge to the tank during the period while Scaltech was cleaning the tank from May to December 2011. Isla made a heat trace photo of the tank in April 2011. In this example photo, the lower red colour shows the level of sludge in the tank. This is how the sludge level of 4.38 metres was determined by Isla. Accordingly, Scaltech made a proposal to Isla for cleaning the tank. We are pleased to provide to Refineria Isla BV, or Isla, this proposal for the online cleaning and processing of the sludges in slop oil tank 3962. It was determined that the tank contains about 33,000 barrels of sludge with the following approximate analysis. Solids at 50%. The offer drawn up by Scaltech, Exhibit 1B, clearly states on page 3 that parties jointly determined that the tank contained 33,000 barrels of sludge, with approximately 50% solids. So this was not an estimate of Isla, but a joint determination. Scaltech stated that it could remove the caked sludge from the bottom. This tank hadn't been cleaned for years, and as a result, a layer of approximately 4.4 metres of sludge had built up on the bottom of the tank, approximately 33,000 barrels of sludge. It had been agreed with Scaltech that Scaltech would remove and process this sludge by means of a so-called online removal process, which would allow continued use of the tank during the clean-up. The online cleaning was used in order to avoid that the tank would have to be taken out of service, which in turn would have required the shutdown of several refinery units. Isla's recon expert states in his report, "It's well known that removing of sludge from oil tanks without loosening it is technically impossible. It is clear that the purpose of injecting the steam and compressed air was the only way to try to get the sludge in fluidized state to be able to remove it online. In this state, the sludge along with the accompanying liquid could be removed effectively with a vacuum truck. If not, the vacuum truck would only be removing part of the incoming heavy slop oil and water with very small amount of sludge present in the tank, which had been compacted due to approximately 22 years of operation. Without fluidizing the sludge, it made no sense to proceed with the online sludge removal operation." Scaltech is an experienced tank cleaning company and had invented online tank cleaning in the United States. Prior to Isla's Tank 3962 project, Scaltech had successfully performed online tank cleaning of slop oil tanks and cat slurry tanks for several refinery clients in the US, including Phillips 66, Murphy Oil, and others. According to Isla's desire to keep Tank 3962 in operation while removing sludge, Scaltech's proposal to Isla states, "Online sludge removal. During the job walk, we determined 3 easily accessible nozzles of 3 inches in size. We will use these nozzles in order to work the tank and remove the sludge online. The process description of the online sludge removal is as follows. Install new manifolds fabricated by us that will allow us to do the following. Inject compressed air, inject 150 pounds steam, remove sludge to the transfer tank. The injection of compressed air and steam will serve for the purpose of loosening the packed sludge in the bottom of the tank. We will alternate the loosening of sludge and removal of sludge via the 3 manifolds. This is the utility manifold that Scaltech built next to tank 3962 that allows to connect to steam, compressed air and water for injection into the tank. This is one of 3 manifolds that Scaltech built to connect to the 3-inch part of the water drainage lines. This manifold has 4 connections. The upper one is for injection of water, the one below is for injection of compressed air, the next one below is for injection of steam, and the lowest one is for connecting a hose to a vacuum truck to remove loosened sludge. This is the same Scaltech online tank cleaning manifold connected to the lower 6-inch nozzle of the water drainage lines. The height of the 2 drainage nozzles of the tank are 1 metre and the lower one 26 centimeters from the tank bottom. This means that online tank cleaning only allows to remove sludge from tank 3962 down to 26 centimeters tank height. We are seeing the Scaltech heavy-duty vacuum truck connected with a hose to the 26 centimeter high 6-inch nozzle, sucking out loosened sludge. All of the loosened sludge was transported by the Scaltech vacuum truck to its mobile processing plant that Scaltech bought to Isla for the online tank cleaning project. The loosened sludge is pumped from the vacuum truck into the plant for processing. A sample of loosened sludge is taken from a Scaltech plant process tank. On the right, we see the 50% solids content sludge as it sat in the tank. On the left side, we see the loosened sludge with the solids content diluted to 8%. The core of Scaltech's plant are high-speed centrifuges. They rotate 7,000 times per minute and with high G-forces separate the sludge into 3 components. We see a water sample taken directly from the centrifuge outlet. Now we are seeing a sample of oil separated by the centrifuges from the sludge being taken directly from the centrifuge. So the centrifuge separates the sludge into clean oil, water, and a solid slurry. The difference between the 3 is hardly visible. Imagine looking into a dark tank and seeing a black liquid. One would be unable to tell if it was oil, water, or solids slurry. The oil is regularly sampled and analysed in the Scaltech laboratory at the plant to make sure that it can be used for further refining by Isla. The specification of the contract is that it needs to be 98% pure oil. In this form, Scaltech removed 200,000 barrels of diluted sludge from tank 3962 and processed them. The Scaltech daily report summary shows that of the original 33,000 barrels of sludge Scaltech removed, all but 81 cubic meters equal to 530 barrels. As such, Scaltech loosened the material with its online removal technique and diluted it 6:1 on average. As Scaltech finished removal of sludge in December 2011, the tank had had a level of 8 meters of material. Isla then decanted the oil to a level of 4 meters by the end of February 2012, leaving water and some sludge. The tank level graph stops on May 11, 2012. For Isla, this was its first experience with online tank cleaning. Isla made a hole in the side of the tank to conduct an investigation. So in summary, Isla's claim is that they made a 24-inch hole in April 2012 and found a layer of 3.85 meters of sludge in the tank. Isla's witness that made the hole states, "I can confirm that at the time of the opening of the hole in tank 2962, the tank contained a mass of sludge in the middle of the tank of approximately 4 meters high. But the contract that Isla issued for making the hole states that it was made at the end of July 2012. So there was no hole in April 2012, and so Mr. Offerman could not look into the tank until July 2012. There is no record of what happened to the material in the tank between April and July. This is a website photo showing a manhole on the side of a tank. This is the type of hole 4.5 meters high that Mr. Offerman says he looked into to see what is in the 39 meter diameter big and dark tank, and through which Isla said that it made the Exhibit 41 photo of sludge in the tank. But again, this hole did not exist in April 2012. After Isla made the hole in July 2012, it contracted AGC to remove the 4 meters of material in the tank. AGC was instructed to remove 4,500 cubic meters of sludge from tank 3962 and transport it to a location to be designated by Isla. This quantity equals almost 90% of the quantity of sludge that Scaltech should have removed based on their contract with Isla. So Isla contracted AGC for slop oil removal and not sludge. It also states that it will be terminated when there is no more liquid/pumpable material in the tank. So Isla knew there was little sludge left in the tank. And Isla knew that since what was to be removed by AGC was slop oil, they asked AGC only for providing a vacuum truck. Scaltech has explained this before to the court and stated it in its June 2015 filing. Isla knew there was little sludge left in the tank. Sludge containing 50% of solids does not flow from one side to the other side of the tank with a diameter of 39 meters by itself. The fluidity of the remaining material consequently appears from the fact that Isla could easily remove the layer without dilution through one exit and quickly by vacuum truck. So, few solids. This is one of the data reports of AGC, showing that they used the northeast connection of the tank to remove material with the vacuum truck. In fact, 210 of the total of 344 loads of AGC were removed from this single connection. Scaltech is of the opinion that most of the 4 meters of material were dirty water, as Isla had decanted off the oil and Isla instructed AGC to discharge all of the vacuum trucks at Isla's land treatment cell. The land treatment cell is used by Isla to deposit water solids slurry-free of oil, where the water can drain and the solids accumulate for further disposition. AGC removed a total of 11 loads from the 4.5 meter high manhole. Since the tank still had floating oil on top of the water layer, AGC took those loads to the Valenciennes oil catcher, where Isla unloads all vacuum trucks which have a load of dirty oil or slop oil. Isla's contract with AGC states, the job will be terminated when there is no liquid/pumpable sludge in the tank or depending on the daily performance. So AGC continues to remove the remaining water through the lower 26 centimeter high 6-inch drainage nozzle and finally hits the sludge layer left behind by Scaltech. After 3 months of dirty water removal, AGC removes a few loads of sludge and takes them to Goat Island. After a few more loads, the AGC contract is stopped. When the court learned about this, it states in its partial verdict in May 2017, the court notes that the other conclusions Scaltech attaches to the documents produced with the statement of February 6, 2017 cannot be refuted promptly. Isla then issued in June 2013 a request for quotation to remove the remaining sludge from the tank to enter the tank and perform repair work. Only solid sludge that could not be pumped was left then. It was removed by driving a loader into the tank and subsequently removing it with a dump truck. AGC made a separate service order for the use of this loader and dump truck. Isla issued, in connection with this request for quotation, a minute of clarification, which states that more slop oil is to be removed with a vacuum truck and that the solid shall be removed with a loader and transported by dump truck. Isla provided with the RFQ and estimate of the amount of work to be performed with a vacuum truck and how much with the loader, and states that the amount of material in the tank is 800 cubic meters. An analysis of the data shows that 62% of the 800 cubic meters is slop oil and 38% or 307 cubic meters is sludge. This amount of sludge equates to a tank height of 25.5 centimeters, which is equal to the lower drainage nozzle's height. Isla's RFQ states that a door sheet is to be made for a loader to be able to enter the tank and remove the sludge. Isla states in its December 2017 filing, as explained, sludge most certainly can be removed from a tank with a pump unless it contains too many solid constituents and is not liquid anymore at all. The rest then has to be scooped out with a loader. This is exactly what AGC did. So only 90 hours were needed to remove the little bit of sludge left by Scaltech in the tank. Let us recap what happened between April 2011 and the end of 2013. First, Scaltech removed 4.25 metres of sludge, leaving 26.9 centimetres of sludge in the tank from May to December 2011. Then AGC removed 3.7 metres of slop oil or dirty water from the tank and leaves a layer of 25.8 centimetres of sludge during the period from September to December 2012. Then comes AGC again in the second half of 2013 and first removes newly added slop oil down to a 25.7 centimetre sludge level and finally removes the sludge left behind by Scaltech with a loader and dump truck. The record is clear. The tank contained in April 2012 26 centimetres of sludge. Isla agreed this in March 2012 and entered with Scaltech into a new contract that states the online sludge removal of tank 3962, contract 32007966, fell short of 84 tonnes of solid, which equates to 1 week of processing. The first week, 7 days, is for free to compensate for the shortage of production by 84 tonnes required in contract 32007966, by means of providing SWMS22 for free for the first week. The obligations for Scaltech International LLC, remaining under the aforementioned contract, have been met. I repeat, work was done for free to compensate for the 26 centimetres of sludge left behind by Scaltech in the tank. Scaltech's expert concludes there were only 321 cubic metres of sludge in tank 3962 in April 2012, equal to the height of 0.269 metres. The picture in Isla Exhibit 41 was not taken in April 2012 from tank 3962. It was taken in October 2013 from tank 0643, which is a freshwater storage tank. The level around the 0.65 metre high sludge mount in the picture is the bottom of the tank and not a 4 metre high sludge level. But then there is the sludge photo of Exhibit 41. Isla stated that it was made in April 2012 through the 4.5 metre high manhole, but we know that the hole did not exist in April 2012. The digital version of the photo shows that it was made in October 2013, and it was not made of tank 3962. The GPS data of the photo shows that it was made from tank 0643. This is located 500 metres from tank 3962. The online tank cleaning case is clear. Isla presented a false claim, producing false documents and a false picture. The online tank cleaning claim needs to be rejected by the court.